Hi everyone, it's Janine here, and in today's video we are going to be learning about the inverse Laplace transform. So the inverse Laplace transform is denoted by the following symbol here, and if the Laplace transform of f of t is equal to f of s, then the inverse Laplace transform of f of s is equal to f of t. And so what we're doing is, given the Laplace transform of a function, we're trying to determine what the original function f of t is equal to. And just like the Laplace transform, the inverse Laplace transform is also a linear transformation. So the inverse Laplace transform of alpha times f of s plus beta times g of s is equal to alpha times the inverse Laplace transform of f of s plus beta times the inverse Laplace transform of g of s. And so basically what this means is that we can take the constants outside of the Laplace transform, and we can also take the Laplace transform of each term separately. So let's go ahead and take a look at some examples. So in this first example here, we have the inverse Laplace transform of 1 over s to the third power. So let's go ahead and take a look at our table. So taking a look here, if we set n equal to 2, we would have an s to the third power in the denominator. So let's go ahead and do that. And so we can rewrite this as the inverse Laplace transform of 1 over s to the 2 plus 1. And in order to match what we have here, we would need to have an n factorial in the numerator. So because n is equal to 2, let's go ahead and multiply by a 2 factorial. And so whatever we do to the numerator, we need to do to the denominator. So let's go ahead and multiply by a 1 over 2 factorial. And now let's go ahead and simplify this. So we have 1 over 2 factorial simplifies down to 1/2. And then we have times the inverse Laplace transform of 2 factorial over s to the 2 plus 1. And so this is equal to 1/2 times the inverse Laplace transform of 2 factorial over s to the 2 plus 1. So this is equal to t to the n. So here n is equal to 2, so we have 1/2 t squared. And that is our final answer. And now let's go ahead and take a look at this example here. So we have the inverse Laplace transform of 1 over s minus 5. So taking a look at our table, we see that we have this case here. So the inverse Laplace transform of 1 over s minus a is equal to e to the at. And so here, a is equal to 5. And so we have e to the at as our answer, and so a is equal to 5, so we have e to the 5t. And so in this next example here, we have the inverse Laplace transform of s over s squared plus 9. And taking a look at our table, we have the following case here. So the inverse Laplace transform of s over s squared plus k squared is equal to cosine of kt. And so let's go ahead and rewrite this as follows. So the inverse Laplace transform of s over s squared plus 3 squared. And this is just so that it's more evident what k is equal to. So we can see here that k is equal to 3. And so we can see from our table that this is equal to cosine of 3t. And let's go ahead and take a look at a few more examples. So in this next example here, we have the inverse Laplace transform of 1 over s squared plus 5. And this is pretty similar to the following, the inverse Laplace transform of k over s squared plus k squared, but we just need to do a little bit of manipulation. So let's go ahead and start off by rewriting this as follows. So the inverse Laplace transform of 1 over s squared plus the square root of 5 squared. And we can do this because the square root of 5 squared is just equal to 5. And so after doing this, we see that in order to match what we have here, we need a k in the numerator. So let's go ahead and multiply by k. And we can see here that k is equal to the square root of 5. So let's go ahead and multiply our numerator by the square root of 5. And whatever we do to the numerator, we need to do to the denominator. So let's go ahead and multiply by a 1 over the square root of 5. So doing that, we have 1 over the square root of 5 times the inverse Laplace transform of the square root of 5 over s squared plus the square root of 5 squared. And so this simplifies down to 1 over the square root of 5 times the sine of kt. So the sine of kt is equal to sine of the square root of 5 times t. And so this is our final answer. So let's go ahead and take a look at this last example. So we have the inverse Laplace transform of 2 over s plus 1 over s minus 3 plus 7 over s squared. So let's go ahead and start out by taking the Laplace transform of each term separately. So we have the inverse Laplace transform of 2 over s plus the inverse Laplace transform of 1 over s minus 3 plus the inverse Laplace transform of 7 over s squared. And as our next step, let's go ahead and move our constants outside of our Laplace transform. So we have this 2 here, and we have this 7 over here. So rewriting this, we have 2 times the inverse Laplace transform of 1 over s plus the inverse Laplace transform of 1 over s minus 3 plus 7 times the inverse Laplace transform of 1 over s squared. Okay, so let's go ahead and take a look at our table to determine what the inverse Laplace transforms are equal to. So we have here 2 times the inverse Laplace transform of 1 over s, and so taking a look at our table, we know that the inverse Laplace transform of 1 over s is equal to 1. And then we have the inverse Laplace transform of 1 over s minus 3. And so we have this case here. So the inverse Laplace transform of 1 over s minus a is equal to e to the at. And here, a is equal to 3. And so we have e to the 3t. And then next we have plus 7 times the inverse Laplace transform of 1 over s squared. So taking a look at our table, the inverse Laplace transform of 1 over s squared is equal to t. So simplifying this, we have 2 plus e to the 3t plus 7t. And that is our final answer. And so that is how you determine the inverse Laplace transform of a function. Thank you guys so much for watching, and I'll see you guys next time. Bye.